Welcome back to my channel. Today we will discuss MSc 109 important questions of block 3 quantitative methods 1. First question is state the assumptions of CLRM, that is classical linear regression model. So the assumptions of classical linear regression model are as follows. First, linear regression model, that is the regression model is linear in parameter, that is model has to be linear in alphas and betas, can be linear or non-linear in variable. For example, yi is equals to beta 1 plus beta 2 xi square plus error term ui. So here the power of beta 1 and beta 2 is 1. That means it should be linear in parameters. It does not matter if xi, that is a variable, is in square or not. The only thing is it should be linear in parameters, that is beta 1 and beta 2 have a power of 1. Second is x values are fixed in repeated sampling, that is x is non-stochastic. हमने यहाँ पे देखो, मैंने यहाँ लिख भी दिया एरर टर्म म्यू आई इज इक्वल्स टू यू आई लिख रखा है, दोनों में से कुछ भी एक चीज़ लिख सकते हैं. थर्ड इज ज़ीरो मीन वैल्यू ऑफ डिस्टर्बेंस टर्म म्यू आई गिवन वैल्यू ऑफ एक्स. The expected mean value of random disturbance term is 0. So expected value of disturbance term with the given value of x is equals to 0. Homoscedasticity, that is equivariance of error term for given value of xi. The variance of error term is same for all observation, that is variance of error term given xi is equals to expected value of ui minus expected value of ui given xi का whole square should be equal to sigma का square, that is homoscedastic. Now next we'll discuss number 5, that is no autocorrelation between the disturbance term. That is for any two values of x, that is xi and xj, the correlation between any two error terms ui and uj is 0. That is covariance of ui uj given xi xj is equals to expected value of ui minus expected value of expected bracket ui minus expected value of ui given xi into uj minus expected value of uj given j is equals to 0. That is disturbance between disturbances or error term ui and uj are uncorrelated. Next is covariance between ui and xi is 0. That is expected value of ui xi is equals to 0, or covariance between ui xi is equals to 0. That is disturbance term and explanatory variables are uncorrelated. Seventh is number of observation n, that is in terms of equation should be greater than number of parameters to be estimated. Next 8 is no perfect multicollinearity between explanatory variables, that is x, that is no perfect linear relationship among explanatory variables. 9th is no specification bias or error, that is implies that regression model is correctly specified. So these are the 9 assumptions of classical linear regression model. Now we'll discuss state the Gauss-Markowitz theorem, that is Gauss-Markov theorem, properties of least square estimator. The least square estimator alpha cap and beta cap are taken as estimator of unknown population parameter alpha and beta. इसे हम ब्लू भी बोलते हैं बेस्ट लीनियर अनबायस्ड एस्टिमेटर, because they satisfy the certain desirable properties, that is best linear unbiased unbiased estimator, that is linear unbiased property of an estimator. Best बता दिया. Most efficient minimum variance unbiased if expected value is equal to true value of the parameter, that is expected value of alpha cap is equals to alpha and expected value of beta cap is equals to beta, then it is unbiased. Linear estimators is linear in parameters, that has already been explained that alpha and beta की power 1 होनी चाहिए. Conditions to hold for OLS estimator alpha cap beta cap to be regarded as blue of alpha and beta. पहला तो वो linear होना चाहिए, ठीक है, in parameters. Second, it is unbiased, that is average or expected value of alpha cap is equals to alpha and expected value of beta cap is equals to beta, और उसकी minimum variance होनी चाहिए among all such linear unbiased estimators, तो efficient estimator हो जाएगा. Thus given the assumption of classical linear regression model, least square estimators in the class of unbiased linear estimator have minimum variance, that is they are blue. तो फर्स्ट प्रॉपर्टी लीनियर है, बीटा कैप इज इक्वल टू समेशन ऑफ एक्स आई वाई आई अपॉन समेशन एक्स आई स्क्वायर. तो अगर हम लेट कर ले के आई इज इक्वल टू समेशन एक्स आई अपॉन समेशन एक्स आई स्क्वायर, तो ये हो जाएगा बीटा कैप इज इक्वल समेशन के आई इंटू वाई आई. बीटा कैप कैन बी रिगार्डेड एज लीनियर एस्टिमेटर सिंस बीटा कैप कैन बी रिटर्न एज वेटेड एवरेज ऑफ इंडिविजुअल ऑब्जर्वेशन ऑन वाई. ठीक है, दिस हैज बीन प्रूव्ड. नाउ नेक्स्ट इज बीटा कैप कैन बी रिटन एज, ये बता दिया. इट इज़ अनबायस्ड, तो बीटा कैप इज इक्वल्स टू समीशन ऑफ एक्स आई वाई आई अपॉन समीशन ऑफ एक्स आई स्क्वायर. नाउ वी आर फाइंड द वैल्यू ऑफ वाई आई. तो समीशन एक्स आई बीटा कैप एक्स आई, क्योंकि हमें पता है वाई आई इज़ नथिंग, बट आपको पता ही है क्या होता है, बताओ. बीटा कैप x1 प्लस एरर टर्म. सो समेशन एक्स है, हमने वाई आई की जगह वैल्यू डाल दी और ये सॉल्व कर लिया. देखो नीचे लिखा भी वाई, देखो मैंने यहाँ वाई इज इक्वल्स टू बीटा कैप x1. फिर हम इसको वैल्यू पुट करेंगे. बीटा कैप इज इक्वल्स टू समेशन अंदर ले जाएंगे, समेशन एक्स आई आ जाएगा, ये कट जाएगा आपस में, समेशन एक्स आई अपॉन समेशन एक्स आई स्क्वायर. बीटा कैप आ जाएगा और ये एज इट इज़ रहेगा. हम टेकिंग एक्सपेक्टेशन ऑन बोथ साइड्स लेंगे. एक्सपेक्टेड वैल्यू ऑफ बीटा कैप इज एक्सपेक्टेड वैल्यू ऑफ बीटा प्लस एक्सपेक्टेड वैल्यू समेशन एक्स आई एरर टर्म अपॉन समेशन एक्स आई का स्क्वायर. हमें पता है एक्सपेक्टेड वैल्यू ऑफ एरर टर्म 0 है. इनको अलग अलग करेंगे, इसकी वैल्यू 0 आ जाएगी. एनीथिंग मल्टीप्लाइड बाय 0 इज 0, सो बीटा कैप इज इक्वल्स टू बीटा, देयरफॉर बीटा कैप इज अनबायस्ड एस्टिमेटर ऑफ बीटा. Last but not least, minimum variance among all such linear unbiased estimator, that is efficient estimate, that is expected value of sigma cap का square is equals to 1 upon n minus 2 expected value of summation ui का square is equals to sigma का square, that is sigma cap का square is unbiased estimator of. तो ये sigma cap का square is unbiased estimator of sigma square. This is very important question. What do you understand by the term composite index? Discuss steps involved in construction of composite index. Very important from exam point of view. Composite index, it is grouping together of equities, indices and other factors combined together in a standardized way to provide statistical measure of overall market or sector performance over time. It includes large number of factors that are averaged together to form a benchmark that is representative of overall market or a sector. It is used to conduct investment analysis, measure economic trends, and forecast market activities. Also used for tracking changes in security prices relative to entire stock market. If an index is constructed by taking positive indicators, then higher the value of index, higher development, and lower the value of index, lower development. That is index related to human development, that is HDR is human development index. Here variables are of positive directional. If variables are negative directional, then it is called human deprivation index. An index is more robust than a single indicator or variable, since an index captures multidimensional aspect of several dimensions and indicators. But the major problem is choosing or selecting the variables and the data availability of the variables. Now the steps involved in construction of composite index. First is theoretical framework, that is provide the basis for selection and combination of variables into a meaningful composite index. Requirement, clear understanding and definition of multidimensional phenomena to be measured to structure variables into various subgroups. Second is collection of data. Collection of data and indicators and dimensions are identified in theoretical framework from reliable sources and to check the strength and weakness of data. So requirement is to check quality of indicators, strength and weakness of each indicator selected, and summary table. Third is imputation of missing data, that is estimating missing value, and requirement is presence of outliers. Fourth is multi-variable analysis, that is studying overall structure of database, its suitability, and requirement is check underlying structure. Fifth is normalization, that is carried to make indicator comparable, and requirement is scale adjustment. Sixth is weighing and aggregation, it is done along the lines of underlying theoretical framework, and requirement is correlation issue. Seventh is uncertainty and sensitivity analysis to assess the composite index, and requirement is to identify possible sources of uncertainty in development of composite index. We have discussed the 7 steps. Now we'll discuss the next. Next step is to back to the main data, that is the main driver of an overall or good or bad performance, that displays the transparency. Okay, driver of composite index, check correlation, that is the requirement. Ninth is the link to other indicators or correlation, that is composite index should be correlated with existing indicators and as well as to identify linkage through regression, and requirement is correlation of composite index with other relevant measure. 10th is visualization of result, it enhances interpretation of result, and requirement to present composite index in clear and coherent manner. Thank you guys. Do like, share and subscribe my channel. Please subscribe my channel and do comment which next subjects you want me to prepare a video regarding the important questions of that particular subject. Thank you guys. Do subscribe my channel.